Good morning, everybody. Welcome to science instruction for today. And today we're going to be talking about trophic cascades. So I'm really excited that we got to this topic because it's going to kind of take into account all the vocabulary we've been building the last 2 days so that you can kind of see how it plays out in real life in the instance of the wolves in Yellowstone National Park. Our goals for today are: Number 1, there are 3 key definitions I need you to record in your science notebook on trophic cascades before, number 2, you view both video clips I have in this folder. Both video clips are fairly short, they're about 5 minutes each. However, I think they give you a great holistic picture of the impact that eradicating the wolves from Yellowstone Park had on the local ecosystem. Lastly, after you view the video clips, you're going to create in your science notebook kind of an informal bubble map, and I'll show you an example of that if you don't know what that is, to show the effects that removing the wolf population had on the Yellowstone ecosystem. So there's nothing to submit for today, but I do need you to have that bubble map in your notebook. Now, before we start with trophic cascades, let's just refresh from yesterday. Yesterday, we were talking about energy flow in ecosystems, and we have our nice energy pyramid here. I want you to think, which picture best represents a secondary consumer, a producer, and an herbivore? Okay, let's start from the bottom. The bottom, as you should know, are our producers. These are any organism that makes its own food using light from the sun. A step up from that would be our primary consumers, which are going to be our herbivores. Remember, primary consumers feed on producers, so they are going to be plant eaters. Our secondary consumers are going to be carnivores or omnivores, and our tertiary consumers also carnivores or omnivores. Now, we have a step above that, and sometimes that happens on the energy pyramids or food chains. Even though it's a 4th step up, we would still refer to this organism as a tertiary consumer. Okay, all right, let's move on for today's topic. Please title your notebook page, Trophic Cascade. And our focus is, what is a trophic cascade? That's really what I want you to have a good idea about by the time we end this lesson. And it's a fairly complex topic, but it's a fascinating one, and I hope you'll agree after you view the videos on the wolves of Yellowstone. Okay, our first vocabulary term for today is apex predator. Remember, apex means at the top or the peak. So an apex predator is a top-level predator with no natural predators of their own. They're going to reside at the top of a food chain or the top of an energy pyramid, and the wolves of Yellowstone were apex predators. Our second vocabulary term is keystone species. A keystone species is a species that has a disproportionately large effect on its ecosystem. The wolves of Yellowstone were also a keystone species. Removing them impacted, again, just every organism in Yellowstone Park, along with some of the abiotic or non-living factors. No one could have foreseen at the time all the effects that removing a small population of wolves. We're not talking about a large number of organisms here. We're talking about a small population of wolves triggering huge, massive change throughout the entire ecosystem. When a keystone species is removed, the ecosystem will change drastically. And our final word for today is trophic cascade. Remember, trophic, we're talking about those trophic levels of our energy pyramid, and cascade, something that's kind of falling down or having a trickle-down effect. A trophic cascade is triggered by the addition or removal of a top-level predator, so in other words, an apex predator. It results in a ripple effect of dramatic changes in the populations of organisms at 3 or more trophic levels. And I'm sure you've guessed by now that the removal of the wolves from Yellowstone triggered a trophic cascade. Okay, so before you view those video clips, let me just kind of give you a tiny bit of background. We are talking about the gray wolf population in Yellowstone, and this kind of started in the late 1800s, early 1900s, so really the time of westward expansion. And here's a lovely picture of Yellowstone National Park. I've never been there, but I plan to go there sometime before I get too old. Now, during this time of westward expansion, more and more cattle and sheep ranches were popping up, and that was really kind of cutting into the hunting grounds of the gray wolf. Now, because of this, it had less area to hunt. Additionally, it had large groups of cattle for easy pickings. So the gray wolves got a pretty bad reputation, unfortunately, because as their hunting grounds shrunk, they started picking off cattle to eat. Okay, now, as you can imagine, this is the livestock owner's livelihood, so they became very upset with this. And in the early 1900s, basically pressure from the cattle and livestock industries resulted in the government making it legal, and not only making it legal, but actually encouraging the hunting of gray wolves. They would actually offer bounties for every wolf pelt that a hunter would provide. So this continued for a few decades, and the last of the gray wolves were killed in 1926. At that point, that is when our trophic cascade, or our changes to the environment, started. Eventually, as the environment degraded, environmentalists mainly and ecologists said, perhaps we should reintroduce the gray wolf. Maybe this will have an impact on the ecosystem and kind of revive it. Thankfully, in 1973, the Endangered Species Act was introduced, and that offered some protection to the gray wolf. However, it wasn't until 1995 that they were able to push through this idea of reintroducing the gray wolves to the Yellowstone ecosystem. And that's when the changes started to begin. And again, I don't think anyone foresaw how dramatic the changes would be. To me, it highlights perfectly why I love ecology and environmental science, because everything is connected. Even if you don't think it is, everything is so interconnected. It's just amazing. So, okay, so having said that, I'd like you to, below your last definition, this is where you're going to make your bubble map. Okay, this just kind of describes to you perhaps what time you may want to stop the video to start making your bubble map. But I'd just like you to draw a circle that says wolves absent, and then connecting to that, you're just going to put all the different effects that you saw or heard about in the video resulting from the wolves being absent. So you can have as many or few bubbles that you want. Some bubbles might have another one that comes off from that. So, if something resulted in something else, but really there's no wrong way to do this. Okay? All right, enjoy the videos, guys. Our take-home points for today. Eliminating a single species, even one small in numbers like our gray wolf, can have far-reaching effects, and as I just said, everything is connected. Number 2, please complete your bubble map right in your science notebook. I am going to put an example of a bubble map that lists some of the effects of removing the wolf population also in this folder. So do yours and then kind of open that one and compare your effects to the ones that they have listed. Okay? Thanks, guys.